So it's been a couple sections since we saw those problems that were just kind of devoted to the exponent rules. We've still seen them as we've gone through some of our polynomial stuff, but section 5.E.1 brings them back with one additional scenario to be aware of. And it's one we didn't bother looking at when we were in those earlier sections. So we have a rule for this. We have a rule for x to the fourth over x to the sixth. It's the quotient rule. And the quotient rule tells us, as it's written right here, to subtract 4 minus 6. Always numerator's power minus denominator's power. But 4 minus 6 is a negative 2. And we have not seen or dealt with any negative exponents at all. Again, it kind of doesn't make sense to think about how would you interpret that. You can't use negative 2 as the number of something, right? You can't count in negatives to express how many there are. So the real question is, what would that even represent? What would x to the negative 2 mean for us? Well, if we take this same problem and we think about it and we do what we did earlier and we write them out, 4x's over 6x's, and then we talk about those common factors canceling, like so. Everything cancels out of the numerator, so you're left with a 1. There's still 2x's left in the denominator, which is an x squared. So the same problem, same exact problem, by the rule gives us this, by thinking about it gives us that, which means they've got to be the same. They've got to represent the same thing. So x to the negative 2 is the same as 1 over x squared. And that's what we want to understand about negative exponents. There's another way to represent them. And so just like this one example, in general, a base to a negative power is the same as putting that base into the denominator and then no longer having that exponent be a negative. Now, this one is what I would call a placeholder. Think of it as this base gets moved to the denominator, and I say moved as if it was a fraction. This is technically anything is a fraction over 1. You could write it that way. So think of it as something over 1, but when you move this to the denominator and there's nothing left in the numerator, we put that 1 there as a placeholder. We kind of saw how it gets there with the canceling of factors, but just think of it that way. We move it to the denominator to turn that exponent positive, and that 1's a placeholder. And the similar approach would be if we do see a negative exponent in the denominator, it would actually be the same, equivalent to taking it and moving it back up to the numerator to make it a positive exponent. And again, in this general example, if this were moved up and there's nothing left in the denominator, it's like that over 1, only in this case we don't need to write an over 1, we just write the numerator. So it's a little bit of understanding how we write fractions that makes sense. But the way I think of it is, a negative exponent means that that base is in the wrong part of the fraction. If you see it here and it's negative, it belongs in the denominator. If you see it negative in the denominator, it technically belongs in the numerator. Okay? So that's some stuff to think about. Primarily this one, because even when we see this example, most likely we'll see it in a problem where we can do other work with it. So we don't really do a whole lot of this, but this is the idea. We don't like negative exponents, so we want to make sure we get them where they belong is the idea. Now to start off with, we'll look at a couple just numbers, some evaluating, but most of our rules are going to be dealing with variables again. So with 2 to the negative third, as soon as you see that negative exponent, that's telling us this isn't where it belongs. And like I said, it's almost like it's over 1, like it's in the numerator, so we're going to move the whole thing to the denominator. When we do that, there's nothing left up top, so we get a 1. And as you move it, all you did is you moved it to change that negative 3 to a positive 3. But now that says 2 cubed, and we know what 2 cubed is. We know how to take 2 times 2 times 2. We've done it plenty of times. We get 8, which means our actual answer there is the value of 1/8. Okay? The next one. Now we've got a negative 2 being raised to the negative third. All I concern myself with is that negative exponent, right? A number can be negative. That's never been a problem. But it's a negative exponent we don't like. So we move the whole thing, and notice the only thing that changes sign is that exponent, right? We don't change the number negative 2. That doesn't work either. Just change the exponent because now you've put it where it belongs. Now you've got negative 2 cubed, which is negative 2 times negative 2 times negative 2, which is a negative 8. And as we know, with a fraction, if you've got a positive over a negative, then that's just a negative fraction. So negative 1/8. And then one more here. Same exact idea as this one though. Negative 2 to the negative fourth. I'll change that to a negative 2 to the positive fourth in the denominator, and now negative 2 to the fourth, 2, 4, 8, 16, and it's a positive because it's an even number of negatives, positive 16, so 1/16. So we do need to always rewrite any number to a negative exponent because we need to rewrite it so we can actually do it, right? We cannot calculate that, but we can calculate that. That's the idea. That's why we like positive exponents on our numbers. And then when we're dealing with variables, it just becomes another one of those things that we want as a goal for a final answer. We talked about earlier in the chapter that we want to make sure there's only one of each base, so we combine similar bases. We have our rules for clearing parentheses, and now something we're going to focus on is not having negative exponents. However, I will say, think of this like the last thing to worry about. Okay, and you'll see what I mean as we go through these examples. So the first one, all I have is x to the negative fourth. So that cannot be a final answer because it has a negative exponent. So I'll rewrite it. It's x to the negative 4, which again is technically in a numerator, so move it to the denominator with the 1 up top for a placeholder, and that becomes x to the positive 4, and that right there is our final answer. That's it. We've got exactly what we want. One of the base, we've got just this single x, we have no parentheses and no negative exponents. That's as much as we can do there. That's kind of our checklist. That's our goal. Now for the next one, what I want to make sure I point out is even though you see negative exponents and we've talked about how we can rewrite them, like I said, don't necessarily worry about them first because even though they are negative numbers, they still follow our rules. And so our rules, if we saw a problem like this earlier, just without the negatives, x to the negative 6, x to the 9th, x to the negative 7th being multiplied, we have a rule for multiplying similar bases. We add those exponents. We're going to go ahead and do that. We're going to use that rule, use all of our rules before worrying about whether we still see a negative exponent or not. So we're going to add negative 6, 9, and negative 7 all together to give us an x to the negative fourth. Now that there's nothing else to do except deal with that negative exponent, that's when we'll move it to the denominator to resolve that issue, which is much faster and easier than trying to move these things first, making a weird fraction with this on top and those on bottom. We don't need to do any of that. We can just use our rules and then worry about that negative exponent. Same with this one. Don't worry about these necessarily being in the wrong spot because we see negatives. Follow the rule. Now I would suggest writing this rule out just to be aware of all the signs. This is our quotient rule. So we've got a negative 5 up top, a negative 9 on bottom. Our quotient rule was numerator's exponent minus denominators. It's very important to make sure that you write that out to see exactly what's happening. A lot of people, if they don't write that, they think it's negative 5 minus 9. Our rule is a subtraction, and that number is a negative. So that really turns into negative 5 plus 9, right? That's what minus a negative would be. And negative 5 plus 9 is a positive 4. And so notice, because we took the time to do that rule first, our result was a positive exponent. We didn't actually end up having to deal with any negative exponents being in the wrong spot kind of stuff. We just did the rule, got a positive exponent, and we're done. So that's another reason why you don't mess with them first. You just do your rules, your exponent rules to begin with. Okay, next one, another quotient rule. I'm going to write it out. Numerator's exponent minus denominators. Again, I see a minus and negative, so I'll write that as plus. Now here, negative 11 plus 3 is a negative 8. So this does need to get rewritten because right now that's not where it belongs if it's in the numerator. We need that 1 for a placeholder and a to the positive 8th, moving that to the denominator. Okay? And the last one, we can work with the a's and the b's separately, just like we saw in an earlier example from the chapter when we were learning our quotient rule. All right, a to the 5 minus 7 and b to the 6 minus 5. A to the 5 minus 7, so that's a to the negative 2. B to the 6 minus 5 will be b to the first. So what's important here? We've been using this 1 placeholder a lot when we moved something to the denominator, but that's because there was nothing else left. Here, when you've got a to the negative second and a b, that b is where it belongs, right? B is a positive 1. This a is the only thing that needs to move to the denominator. So grabbing that base and moving it, the b is still up top, and it's just the a that's now to the positive second when it gets moved to the denominator, and that's our final answer. So no 1 over is there because there was still something left in that numerator.